So here is the solution video for the first review in the final Unit 4. It's like the third time we've tested over some of the parts on Unit 4. The first part says determine all the possible rational roots using the rational root theorem, and we know that those are all the factors of 12, the constant, divided by all the factors of that lead coefficient. So in this case, it's all the factors of 12, just divided by 1. So you got these options. You can use your calculator or a graph, and you can find one of the x-intercepts. So it looks like we knew that 1 was an x-intercept. So we know x minus 1 is a factor, and then we use synthetic division. And again, we can show, plugging in 1, we get a 0. And then we can use these coefficients to create a quadratic, and then we can double bubble from there and get these. And so not only do we know that x minus 1 here, we also know x minus 4, x plus 3. Thus, we know the solutions, the roots, the zeros, are 1 comma 0, negative 3 comma 0, and 4 comma 0. You can say them as coordinates, like I just said, or you could just write them like this and just give me the x values that do produce a y value of 0. Over here, it's the same thing. It's just all the factors of 8 divided by all the factors of 1. You can use the graph to find 2 comma 0. Use 2 to then break this down. In this case, this takes 2 steps because we use 2 to get 1694, meaning x cubed plus 6x squared plus 9x plus 4. And then we do it again with negative 1, and we break it down, and then we get a quadratic, x squared plus 5x plus 4, and then we can double bubble. So we got x minus 2 from the purple, x plus 1 from the green, and we got another x plus 1 and an x plus 4. So we actually have a multiplicity of 2 for our negative 1, 0, because there are 2 of these, x plus 1 and x plus 1. These are reminding us that rational things come in pairs. So irrational solutions come in pairs. So if negative radical 6 is 1, then radical 6 is 1. If 5i is 1, then negative 5i is 1. So the least degree this has to be is at least 3. Has to be 3, 1, 2, 3. And the least one this has to be is at least 4. 1, 2, 3, and then its partner. So it's got to be at least 4. It could have been more, but it's got to be at least 4. Factored form, we're just multiplying this out to get the x squared minus 6 and the x minus 4, of course. And then if you want it in standard form, just go ahead and multiply the purple. Same thing over here. X minus 5, x plus 5 is going to lead to x squared plus 25, and then multiply it out to get to standard. All right, find all the zeros. Again, you're using the graph, so look at it. Dude, negative 2, for sure. That's one of them. So start with negative 2. Start with negative 2, make sure the coefficients are lined up and there's nothing skipped. They are, so fourth, cubed, square, x's, numbers. Nothing skipped, so we're good. Use the coefficients and use negative 2 because we know that's one of the zeros, and we just proved it because we get a 0 there. And then we're left with 3x cubed, 1x, negative 1x squared, 27x minus 9, and then from there you're like, oh, I have 4 terms. I can factor by grouping. So you factor that by grouping, and now you have it all. You have x plus 2 here, 3x minus 1, x squared plus 9, and you've got everything. So the zeros are going to be the negative 2, the 1/3, and then this guy here is going to give you that plus or minus 3i. Okay. Use the graph, increasing and decreasing. Again, these are given information if you have the graph where it's going to go up and then down and then up. So we have, looks like 3 x-intercepts, 1 y-intercept, a maximum here at negative 4, 7, and a minimum there like negative 1.33 comma negative 2.48. So it's going to be increasing from here to negative 4 and from negative 1.33 to infinity. The only time it's decreasing is when we go from the maximum to the minimum. Right? So the intervals of increasing and decreasing are all about the x values and when what's that happen. End behavior, again, as x goes to the right, it goes up. As x goes to the left, it goes down. So this is a no graphing calculator one. We got to graph it, and you can say degree 6. Look, 1, multiplicity of 3, multiplicity of 2, so that's a total of 6. And x-intercepts are 0, negative 3, and 2, 0, negative 3, and 2. The multiplicity of 2, it's going to bounce, which is why we bounce at 2. It's going to level off at negative 3. That's me leveling it off. and then it's just going to go through at 0. We know that if you multiply all that stuff out, the lead coefficient would be a -2, and the degree would be x to the 6th. The big dog would be -2x to the 6th. So we know it looks like this, up, 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 down. Right? They're both pointing down. The lead coefficient is -2. The end behaviors are both down. And again, multiplicity of 1, multiplicity of 3, multiplicity of 2. So through level bounds. And we got a factor. So this is the difference of cubes, in which afterwards we have to then factor using the quadratic formula. This has 4 terms, so this is factor by grouping. Again, get everything on one side of the equation first, and then factor by grouping. And when you're left with something like this right here, that 5x squared plus 1, you can continue to solve by finding the imaginary solutions by using square roots. Again, here you use the quadratic formula. Here you can use square roots. This one's a 3-termer. Get everything on one side, and you can just double bubble. Here you're going to get imaginary. Here you're just going to get real numbers by using square roots. Here is a sum of cubes. Use the sum of cubes formula, and when you're done with this guy right there, you're going to use the quadratic formula to continue going. This is factor out the greatest common factor first, so take out 4x cubed, and what you're left with is the difference of squares. You're like, oh my gosh, look at that. When I factor the difference of squares, I get another difference of squares, x squared minus 4. So you got to keep going. You get all these factors, and then you get the solutions based on them. This one is double bubble, and then once you get the double bubble, you can use square roots here, and you can use square roots here to find the actual solutions to that, meaning when is x squared plus 9 equal to 0? Well, that's plus or minus 3i. And here's your box problem. Same as all the box problems, we're going to take corners and we're going to cut off squares of x by x squares. So the original width was 20. Well, now it's going to be 20 minus 2x. The original length was 15. Now it's going to be 15 minus 2x. And when you fold that bad boy up, you're going to get a height of x. The domain is between 0 and 7.5. Like, this thing is only 15 long here. So you can't cut off from both sides more than half. You can't cut off 7.5. You wouldn't have a box anymore. You got to cut off less than 7.5, which is why I use a parenthesis here. Then I'm going to graph it. So this guy right here, really I'm only interested in this hump. This is outside of the domain and this is outside of the domain. And we want to know the maximum. How do you create the biggest box? Well, you take corners and cut them to 2.83 by 2.83 corners, and then you're going to get a volume that's 379.04. I think on the test we asked you to round to the nearest thousandth. So we're talking 3 decimal spots. If you want to know the dimensions, well, there's the height, 2.8. 20 minus 2x is the width, so just plug in 20 minus 2 times 2.83. And then if you wanted the other dimension, 15 minus 2x, well, just do 15 minus 2 times that. Okay, that is your video solution for the box problem, for solving by factoring, graphing, giving some equation, and using your calculator to increasing and decreasing. And then all this long division or synthetic division to kind of get you started by taking roots and breaking things down into factored form or standard form. Okay, hopefully this helps.